As per the question, you're given a string S and you have to find the number of unique palindromes of length 3. Now unique palindromes of length 3 have first and last character as same and only one character in between. Okay. There's one more condition to it, that it should be a subsequence of S. Now by subsequence we mean it should be in the sequence only, like AAB is a subsequence, ACA that is also a subsequence, and so is BCA. It can be continuous or it can be discontinuous, but it has to be from left to right only. The third thing is that you have to only consider the unique answers. For example, ABA. This is a valid answer, but so is this A with B with A. Both of them will be counted as only one. That way we have to find unique palindromes in the given string. For the intuition, let's start small with A. So any palindrome starting with A will be ending at A as well, right? So if we want to find all such palindromes, what we can do is we can create two pointers, one L left starting from the left side and one R starting from the right side. Now if we keep moving, we'll see the first time we encounter A is at position 0, and from right the first time we encounter A is at position 4, and anything in between like ABC, anything in between can be considered eligible candidates for a palindrome. For example, let's say AAA is a valid palindrome. Similarly, ABA is a valid palindrome, and so is ACA. So for A, we found that we have three palindromes starting with A. If I talk about B similarly, we can say that moving from L, we found that B is at index 2. Similarly for R means right, I found that B is at 2. So now B underscore B, if I consider, it cannot be true because both are at position 2 and there is no gap, like there was a gap in case of A, there's no gap in between two B's. In fact, there's only one B in this case. So we can say that there are 0 palindromes that start and end at B. Now if we keep following this approach, we'll see that for A we have 3 palindromes, for B we have 0, and similarly we can go up to Z, and whatever the answers be, we can sum them up and the total sum would be our answer. Now if we look carefully, adding the L, the R and the gap, we are traversing the whole array for N. N means we are traversing the whole array once for each alphabet. So for 26 alphabets, we're gonna traverse it for 26s n times, and that would be our time complexity. Okay, so coming to code, the first thing we would want to do is convert our string into a character array. We'll also initialize variables like our answer, which in the end we would be returning. Now for each alphabet in our string, what we're going to do is we're going to find all the palindromes associated with it. So we'll say for int I equals 0 up to 26 for the 26 letters, and for each alphabet that is present in the string, there's going to be a first occurrence and there's going to be a last occurrence, which will denote by left equals 0 and right with length minus 1 as the last position. These are only the initial positions. For the final positions, we'll run while loop till we don't find that character. So we'll say while array of left, right? Array at left is not equals to character of A plus what is our current index? Our current index is at I. So we'll say A plus I, right? While these are not equal, what we're gonna do is we're gonna increase the left. One thing we also have to take care is, let's say Z is not present in the whole string. In that case, what it'll do is it traverses from left to right completely, not getting the alphabet even once. In that case, what we want to do is we want to discontinue our while loop. So we'll say while left is less than array dot length, and now only if the gap between them is positive, like left is less than right, only then we can find some palindromes in between them. So we're gonna say if left is less than right, then in that case what we're gonna do is for each alphabet right, we're gonna create a boolean array called palindromes equals new boolean, and size of it's gonna be again 26. Why 26? So let's say we have two a's, a dash a. In between the a dash a, how many alphabets can come that can create unique palindromes? So we have only 26 possibilities for that, right? From a to z. So that's why we'll take the size as 26. And then what we'll do is for every alphabet in the gap that we find, we're gonna mark that position as true. So we'll take 0 for a, 1 for b, and similarly 25 for z. So we'll say for int a equals to left plus 1 until a is less than right. Okay, we're gonna mark it as true. So we're gonna say palindromes array of a minus of a. Why minus of a? Let's say the character at that position is c. Now c minus a, the answer is 2, right? So for c we'll say palindromes at position 2, we're gonna mark it as true. Now once we mark all these characters in this gap that can form palindromes, what we're gonna do is we're gonna count these palindromes. For boolean bnr palindromes, if b is true, then we're gonna simply add it to our answer. Let's try running this. Okay, our test cases got passed. Let's submit the full solution. Okay, thanks for watching guys. I'll see you in the next one.